So, today we are talking about properties of real numbers. This is lesson 1.9 for those of you that are doing a good job of keeping up with your agenda. Okay, for those of you that aren't, my suggestion is to get that way. So, properties of real numbers. Okay, what I want you to do is with somebody you're sitting next to, I want you to read through. We've got 1, 2, 3, 4, 5, 6 properties that we're going to talk about today. Okay, I want you to discuss those 6 with someone you're sitting next to next minute or so. Okay, which ones do we feel like we remember? Which ones do we feel like we've never heard of? Okay, ready, set, go.
So, I kind of reviewed yeah, I'll pay my friend I'll remember. I kind of remember that one. And I kind of remember that one. I know, I get that a lot. Thanks. I even get it from people that I don't know. I'm hoping. Do you remember that one? Do you remember that one? I remember. Do you remember that one? No way. I did not remember that.
All right, let's go ahead and come together. So, your project starting next week is going to be your group is going to be responsible for information regarding all of these properties of real numbers. Okay, and we'll talk more about the project probably at the end of class today. But just keep that in mind as we're rolling through it. Okay, in math, properties are statements that are true for any numbers. They justify steps when simplifying expressions and solving equations. Okay, the commutative property is the one that I think most commonly gets the duh, like that's obvious statement. Okay, and that is that the order does not matter with addition and multiplication. So what do they mean by that? Yeah. Yeah, that's right. So A plus B is the exact same as B plus A, okay, as an addition example. That's all they're saying. Which again, I think to us sounds obvious, but you know, however many millennia ago, where algebra and arithmetic kind of were first starting, someone creating this property made it make a lot of sense to people. Like it doesn't matter if I add 2 and 3 together first, okay, or if I switch them and I go 3 and 2, I'll still end up with the same answer, right? So a couple others, okay, just so you see it with numbers. 7 plus 5 equals 5 plus 7. 3x plus 8 equals 8 plus 3x. Y plus 9x equals 9x plus y. Okay, the multiplication examples are basically the exact same. Okay, so you've got your order doesn't matter when you are multiplying two things together. Okay, because the same result will occur. These examples might seem excessive. It will be useful for you when you are on your project, I promise. Okay, any questions over commutative property? It is most commonly mispronounced commutative, but it is not commutative. There you go. Yeah, kind of weird word. Commutative. All right. Associative. Does anybody remember associative property? It's all right. So associative property is all about the like grouping. Okay, so if you want to think of it, you're think of it as numbers that we're associating with each other. Okay, what do we use to group numbers together in math? So that's combining them together. But what if we're just wanting to say, hey, these two numbers kind of belong together? How would we show that? Parentheses. Yeah, that's exactly right. Okay. Okay, sorry. I've never had a student take it so personally. Okay. Grouping does not matter with addition and multiplication. All right, so tell me this before we write some examples. Why on commutative and associative is it only including addition and multiplication? Why do we not include subtraction or division? Yeah, that's exactly right. Okay. And so I think a lot of times we get stuck on when you get questions and they're asking you for the why. Okay, that's a great why. Okay, giving a very specific example of why it's different. Okay, so if we have 8 plus 9 plus 7, let's say that we have parentheses around the 8 plus 9. All the associative property means is you can move those parentheses. As long as all you're doing is adding everything, you can move those parentheses kind of wherever you want them. So then you could have like 8 plus 9 plus 7 and group up the 9 and the 7 if you wanted to. Okay, so just a few more examples for the, oh my gosh, for the addition one. It's a Z. So in algebra, and this is just something you should get used to, okay, in algebra, 2's written by your teacher should almost always look like this. Okay, they'll have the loop. Z's will have a line through it.
Like a 7. That's what
That's all right.
Which one? What number are y'all talking about? This one?
Yeah.
Well, that's all right. You'll figure it out. You'll get used to it. When I first started teaching, I used to, well, actually, I guess my whole life, I used to just write my 2's like that, I think. Well, I didn't change them until my students started complaining. And then I was just like, oh, yeah, that's not very good. So I changed. It's okay to change. Okay? It's okay to change. Especially when 13-year-olds like shame you into changing. But that's fine. All right, for multiplication, okay, the grouping is the same thing. Just trying to give you as many combinations as we can in a short amount of time. Again, all these examples will be useful for your project.
I was kidding.
Guys, he's just joking. We'll talk about it. All right, guys, we're going to go to identity. I'll scroll up just a little bit. Okay, identity property is all about doing an operation to a number, but you don't want to change the value of that number. Okay, so in addition, what's the only thing that I can add to a number that won't change it? Okay, in multiplication, what's the only number that I can multiply to something to not change the value? Okay, so the identity property is all about keeping the value of the number. So we have x plus 0. That would equal x. 4a plus 0 equals 4a. And the reason I think identity property is actually a really important one, because I think we know this, and like if I say in a vacuum, does that anybody not know what that means? No. So like when I say in a vacuum, I'm saying out of context. Like if I just told you, hey, 4a plus 0 equals 4a, does that make sense to you? Most of us would say yes, that makes sense, because you're not adding anything to it. That's in a vacuum. Out of the vacuum is in context. If you were working on a problem like this, and maybe this was like your last step before solving the equation, you see 4a plus 0, students' brains start to try and like walk down pathways that don't exist because they think it's supposed to be more difficult. Does that make sense? Or like making the problem too hard on ourselves. So it's important to keep this one in mind. As you get older and move forward in math, you'll be more comfortable working with zeros. But I think at this point, we're actually kind of uncomfortable when we see a 0 pop up on our sheet. We feel like we did something wrong. Same with fractions. Okay, so 7 times 1 equals 1. That's the multiplication example. Okay, so a couple other examples along those lines. 1/4 times 1. The fractions times 1 always seem to trip us up. Maybe just because it's a number less than 1, so we feel weird about it. I don't know.
From there?
Yeah. And then unfortunately that led to Omar showing me where he was hiding his phone. So I'm going to have to give you a mark, Omar. It was just the worst timing all the way around.
Wait, Miss Minute.
What's up, D? Mm-hmm.
Wait, Mr. Bennett, what's 7?
What's 7 times 1? 7.
Why is it 1?
Dang it.
Oh.
There we go.
Oh. You made me burn it off. Kind of. Wow. Miss. I saw it on TikTok and I want to try it. Like,
First mistake ever.
Yeah. I know, guys.
Yeah. What's the square root of 169, Jet? All right, moving on.
Love the bottom pink highlighter.
Just look it up. Okay. Good job, Jet. Proud of you. What?
Step 4. Step 4.
That one I believe is
Step 3 is the folder.
yeah. So step 4 is going to be still in school suspension. You have ISS maybe for like 3 days, or maybe just that day. But that one is a like letter in your file. So when you're applying for high schools and stuff, they'll see that you've had ISS.
No, we didn't.
Step 4. All right. Inverse property. Step 8 is bye. No, I don't know. Uses. Okay, so inverse. What does inverse mean? D. Yeah. We could say opposite. Okay, opposite would be another way to say it. So inverse, okay, uses the opposite to cancel out I put the cancel out. Oh my goodness. No, don't. You're good. I just need to rewrite it. My pen keeps like making random marks. We're so rude this morning. Okay. So examples. Okay. If I have 10, okay, and I want to add something to it that's the inverse, what am I adding to it?
Cancel it.
Yeah.
Cancel it.
Yeah. How would I do that?
By not adding it.
That won't actually cancel it out though, will it?
By adding.
Where does this property come into play? Yes. And what specifically, and it's okay if we don't know this, children, it's okay. With the inverse property, okay, where would this come into play in algebra?
I know the answer.
We've only done it. We've only done one little lesson over it. And after we get done with this unit, we're going to hit it real hard. It's solving equations. Okay. The backbone of algebra, solving equations, we use inverse property all the time. Right, Izzy? You got close. Okay, so for multiplication, when we say cancel out multiplication, what are we actually saying? So it's actually not down to 0, okay? Because if we take a number and we're multiplying it, okay, to cancel it out, we actually want to turn it into a 1. Because if we cancel it out to a 0, then everything on that side that's going to be multiplied by this number is going to just be 0. So we're basically canceling out the whole problem. Okay, and we don't want to do that. What we want to do is create ones, because when you multiply 1 by something, what happens? Yeah, it doesn't change its value, right? It keeps its identity. So what's the inverse, or how do we get 10 to a 1? You're going to multiply it by, why would 10 times negative 9 cancel it down to a 1?
Wait, no.
You were thinking, well, we need to think multiplication, right? So if I have a whole number, I have to multiply it by the inverse. Inverse means I'm going to flip that whole number into a fraction, okay, and put it over 1. So what's 10 times 1/10? It's 1. Do we all know why it's 1? Because I said so. So here's what it should look like, right? This number right here, okay, would be 10 over 1 times 1 over 10. When you're multiplying fractions together, you multiply across the top. So 10 times 1 is 10. Oh. So I'm saying sometimes this new pen just like vomits ink all over the tablet. It's the pen. All right. 1 times 10 is 10. What's 10 over 10? 1. Okay. So what about if we have negative 1/3? What can we multiply that by to get 1? Negative 3.
Did you get that? Oh, because it's okay. Never mind.
Yep. So we start with the fraction on this one. We want it to cancel out. Okay, so we multiply it by the inverse, which means we're going to flip that fraction upside down. And it's still negative, so now it's just negative 3. Okay. So if we had b, how could I multiply something by b to get 1? Don't change what we're doing. Take the whole number. We'll pretend b is a whole number. Say that. Yeah, there you go. I heard it twice. 1 over b. That equals 1. Wow. I didn't invent it, but thank you. And then any fraction, okay, you just flip it, multiply across, it'll be 1, okay? So if you have 5 over 4, you need that to cancel out, multiply it by 4 over 5. Okay? This property, guys, I'm not going to put like just ultimate importance on any one of these. This one for algebra, I think, is the most important for you to really know, okay? You really, really need to understand the inverse property. So whoever has this property for your project, which you won't find out until I assign it to you, it'll be important, okay? Property of 0. Let's keep going. We're almost done. Property of 0. Property of 0 means anything multiplied by 0 equals 0. Examples. 5x times 0 equals 0. Go figure. I know. X plus 7y times 0 equals 0. All right, distributive property. I would say probably the second most thought about one in algebra. Okay, this is a property that is about children. Thank you for apologizing, but
She doesn't even care.
Don't apologize.
it feels as though if we apologize, that means we should try and fix it. And I'm talking to the group, not to the person that apologized. Multiplying a value to an expression in parentheses.
What did that say?
What is that?
Multiplying a value to, yes,
I need to see Gavin.
he's on his way.
Let's read expression in parentheses. What is that?
In,
That's not an in.
That's not a. That's a ew.
Use the word misspell.
What?
That's like an upside
Why would you write the I one?
We're gonna say
Yes. There we go.
I'm gonna fail all of you. Okay. Multiplying a value to an expression in parentheses because context clues are impossible. 5 times the factor x minus 2. Okay, so distributive property says that you have to multiply this to each term inside of the parentheses. This is something we've done before. Okay, 5 times x is 5x. 5 times negative 2 is negative 10.
Wait, what?
Wow.
You take the number on the outside. Everybody look at what you wrote down. You take the number on the outside, which is 5. You first multiply it to the x. That gives you 5x. You then multiply it to the negative 2. That gives you negative 10. Okay, so let's say we have 1/2. And then in parentheses, 20x minus 4. What is 1/2 times 20x? What is a half of 20 is what I'm asking you. 10x. Okay? Guys, if anyone ever says, what is 1/2 times another number, just take the half of what that other number is all you need to do. That's why they call it a half. It's true. Okay, next one. Let's say we have A, and then in parentheses, B plus C. What would that equal? I want you to show me what that should look like. Don't do that. Try and fill in those last two. So we've got A, and then in parentheses, B plus C. And then the last one, we've got negative 7, and in parentheses, x minus y.
I know it.
All right, who wants to share the first one? D.
It'll be A, B, A.
AB plus AC. Solid.
Oh, I knew that. It was AB plus AC.
It's just AB plus AC. We can't add them together unless we know what all the variables are, so we'll just leave it like that. Yep. All right, who wants to give the last one? Izzy.
Oh, why?
So this one is a tough one. We got negative 7 on the outside. We have negative y on the inside. So when you do a negative times a negative,
Oh, it's a positive.
it's going to be positive.
7x. Why?
Negative 7x plus 7y.
Probably.
It's pretty good.
You saw that, right? You saw it.
Okay.
You saw it.
Oh.
So, if we were to name that property, what would number 1 be? We've got 4 plus in the factor a plus b equals 4 plus a plus b. Izzy.
Associated. I knew it.
Oh, yeah.
Does that make sense?
Yeah.
Okay.
I was looking at the wrong one.
So, we see the parentheses. Guys, scroll back through my notes, see which ones we were grouping together. Okay. Associative property is all about what numbers you're associating with each other. We use parentheses for that. Okay. What about the next one, number 2? We've got 2 times the factor x plus 9. What'd you say, Cohen? Distributive. Aluminium. Okay. See if you can fill out the rest of those. 3 through 6, I think we should get. 7 and 8, let's see if you can figure them out. Yeah, see if you can finish off the table.
Oh, wait, but
Just distributive.
It's this. Oh, it's.
I think.
Yeah, it's saying whatever.
Whoa.
I wonder.
What are you trying to say?
I think it might be inverse. But if it was inverse, it would be 1.
I wonder who that is. I wonder who that is.
Yes.
Oh, you ain't do this.
Oh, yeah.
And I guess wait, what's up with the other?
I'm not signing it.
You liar.
What's up with the other we have on there? If I was there, it better be like.
I think that's one of those instances where like beggars can't be choosers. Like if you need some deodorant, Axe is probably better than nothing. Allspice. All right, I'll put them up here. Number 3. If you just put identity, that's fine. You don't need the multiplicative. Number 4. Number 5. Number 6. Okay, so number 7. Name the additive inverse of 16. So what's the inverse of 16? Yeah, so inverse is either the opposite negative if we're adding, okay, or 1 over 16 if we're multiplying. This one says the additive inverse. So what do we think? Negative 16. Okay, so along those same lines, number 8 is asking for the multiplicative inverse. Yeah, say that one time if you can accurately. Multiplicative. Multiplicative. Yes, there you go. There you go. Cohen's got it. That's why I 7/3. Okay, is the inverse of 3/7. Okay, you have your assignment. Okay, the nice thing about this assignment is there's no math to do. Okay, it's all grouping and associating. Okay, no, that's not the project. That's your warm up for the project. Okay, so I think you can finish this before you leave today. You have 30 minutes. Okay, 30 minutes. No, one side. Okay, make sure you read the directions. Okay, the first half just says name the property. Okay, so it's showing you one. All you have to do is name it. The second half is just finish out the example based on the property that it gives you. Okay, so use your